Hello and welcome to SudoKanard. We're here to solve this clonal Renban Sudoku that was featured in the latest Sudoku Grand Prix by Turkish author Can Erturan. Oh, I wrote Sari Alan. That's a mistake. That's a copy-paste mistake. I think I made the same mistake in the previous video. So this is really by Can Erturan. And this was worth 113 points, which is a lot. And I did not attempt the puzzle during the contest. I solved it afterwards, and I remember it was really, really difficult. But I managed to pull it off, so I hope I will be able to do it again. So the special rule here is that we have, well, four instances of two shapes, this square and this rectangle. So we have four rectangles and four squares. And of four similar shapes, two of them are clones with digits in the same place. For example, if this and that are clones, then we could have a 1 on the same position, and let's say a 3 here. That seems to work. Or perhaps the clones are those ones or those ones. So this will have to be determined as part of the puzzle. And the same is true for two of those rectangular regions. And then the other two must be Renban lines, Renban groups, which means that inside such a square we must have four consecutive digits and four consecutive distinct digits. Well, they must be distinct by the rules of Sudoku anyway. So this is those are the rules. And now let's move on. So something we have to be determining which are clones and which are Renban. And the first thing I'm noticing is those digits 2 and 6, which means that you can't put four consecutive digits without hitting the 2 and the 6. We have just the digit 1, for example. We have 3, 4, 5, but we can't use the 2 or the 6. We can have 7, 8, 9 as consecutive digits, but the 6 is not here. So this has to be a clone. So I think I will use some coloring. Let's say orange for Renban and green, let's say green for clones. So this will have to be cloned somewhere. So that's the first thing. I'm saying that those two can't be clones of one another. And the reason for that is that this digit would have to be the same as this, which is impossible. We can see something with Sudoku, which is that with those twos, we know that there is a 2 in here. And so this tells us that this can't be a clone of this, because it would have to be a 2 somewhere in here, which doesn't work. So we can see that for rectangles, the clones are, well, maybe those two. Well, actually, yes, we could have a 2 in here. We could also have a 2 in here, so this could possibly be a clone of this or that. Or we could have a clone here of that. I'm also seeing that 1 must be somewhere in here. No, so this can't be a clone of this. So this could be a clone of that. This could be a clone of that at this point. So we'll have to investigate further. What next? This is a real question. And I didn't rehearse, as you can see. So perhaps this 3 seems, yes, the outlying digits are interesting regarding the possibility of being Renbans. For example, we know because of this one that 1 is somewhere in here. If this were to be a Renban group, then 1 would be with the 2, but the 2 is not available. So this is definitely a clone. And it's not a clone of this, so this has to be a Renban. And this is very interesting because 7 is not in there. So 8 and 9 can't be in there either. So that's an 8-9 pair. And the Renban here just means that we have digits from 1 to 6. And I will just pencil mark the 6s in here, the 1s are in there, the 1s are in there here. Which is kind of interesting because we have to determine which of those two are clones of this. And I'm saying that, well, one of them is a clone of that. So one of them will have the ones in here or in there. Because of this, that's not the one. And I'm also saying that the clone region won't include a 2. If this is the clone, then we have a 2 here. If this is a clone, then we have a 2 there. This is not saying that much. Oh, I'm saying that 6 is not in here. 6 has to be somewhere in here. Oh, something else I'm saying. Yes, that's interesting. If this is a Renban, not containing the 3, then 1 and 2 must be here, but that's impossible. So this is the clone. And this is a Renban. Right. So that's a place to start. So this is a clone of that, which means that 3 is nowhere in here, so there's a 3 in there. And 2 is not in the clone, so 2 is here. And that's a Renban. It could be from 1 to 6. So the range could be 1, 6. It could be 2, 7. It could be 3, 8. But in all instances, all digits from 3 to 6 are in there. All digits from 3 to 6 are in there. And those can only be from 1 to 7, 8. So this is from 7, 8. And that's interesting because now we know that from the options I was mentioning, 1, 6, 2, 7, 3, 8, we know that 3, 8 is not possible. Because if we have all digits from 3 to 8, then this cell would have no value. So we are either from 1 to 6 or from 2 to 7. So 8 is missing. There's an 8 in here. And the other missing digit is either 1 or 7. So this is from 1, 7, 8. And there's a 2 in there. And 2 is in here. That's really, really heavy pencil marking. So I will just put a 2 in there. And that's it for the time being, I think. Oh, there's a 1 in here. Not sure it's what. Oh, and a 3. Oh, yes, 1, 2, 3 are not in here, so they must be on this row. This is a 1, 2, 3 triple. And this is, so 6 can only be here, and it's surrounded by 4 and 5. Now, and this box 3 can only be here. So this row still needs 1, 4, 5, 6. So this is from 4, 5, 6. This is also from 4, 5, 6. And let's remember that this is a clone of that. So because of this 6, because of this 6, none of those here are 6s. So that's the 6 on this row. And the digits are 1, 4, and 5. And they can be cloned up there. So what about this digit? This is from 6, 8, 9. And because of that, it's not a 6, because we know that 6 is somewhere in here, so that this is 8 or 9. And this digit is the one missing here. This is 3, 3, 8, 9. And so 3 is in there, so those are from 7, 8, 9. The 7 is in here, that's not a 9. We know that both 4 and 5 are in here. We know that 7 is around here. So it is cloned to one of those positions. And interestingly, we have a 7 in there. I'm saying interestingly because now this is not a clone of that, because 7 can't be in here. So this is a Renban. Oops. Like this. And there are quite a number of options for that. So this could still be a clone of this, I think, with a 7 in this cell. Or this could be a clone of this. I think I remember. Oh, I've been missing this. This 7 here prevents this from being a 7. So the 7 is actually here, which means, knowing that this can't be a 7, that this is not a clone of that. So this is a Renban, this is the clone. And we can place a 7 in here. So the whole attribution of the statute of clone and everything has been resolved. But the puzzle still needs to be solved. And it won't be done that easily. With those 2's, we know that there is a 2 in here, which is really interesting regarding the Renban. We know that there's a 2 in it, so the digits are either 1, 2, 3, 4 or 2, 3, 4, 5. So we know that 3 and 4 are in there. And knowing that there is a 4 here, 4 has to be in there. There is a 3 and 1 or 5. So 6, 8, and 9 are all excluded from those, so they must appear in there. This row still needs to, actually only 2 and 3 fit in there. And those are from 1, 4, 5, with the 4 necessary. So those are 8 and 9. And this is cloned into this cell. So we get an 8, 9 pair. So some coloring will probably be necessary. I'm saying that 6 is not here, so this is a 6, 7 pair. And this is 8 or 9. Those are cloned into those cells. 6, 7 pair here, 8 or 9 there. Yes, there is definitely something going on. So let's use some more coloring about those 8s and 9s. Let's say this is here. Oh, that's quite annoying. So this is also there. And now I remember something that took me very long to see, which is that, so this digit is the same as that, and where does it appear? Inside this box. Let's see. It's not in here. It's not in here, and definitely none of them are 8s or 9s. So the real digit is this one, so it's an 8. So this took me a very long time when I solved the puzzle after the contest. So this is 8, this is 8, this is 8. And that's a really nice logic, by the way. But just by itself, it justifies the high number of points of this puzzle. No, just that is not enough. So that's an 8, by the way, and this is 9. and this is 9, so that this is 8 and it's cloned into this cell. You get 9 and 8 in there. Alright, so that's some definite progress. This is 7, by the way, so that this is 1, this is not 1, this is 1. So that this is 1, this is not 1, and this is not 1. Here we need 4, 5, and 9. 9 is in here. That's a 4, 5 pair. Down there, those digits are from 2, 4, 5. Those digits are 3, 6, and 7 in some order. That's not 7, and 3 is in there. And those are from 4, 5, 6, 7. That's not so interesting. Let's think about those. What are the options? 1, 4, 5, I think. Yes, 1, 4, 5 again. And they are cloned into those cells. I'm saying that this 9 is somewhere in here. So that this is 9. 1, 3, 4, 5. So we need a 3. 3 is in here. That's not 3. This is from 1, 4, 5 again. We get a 1, 4, 5 triple on this column, so that's not 1. This is from 2 and 3. This box still hasn't been addressed. Here on this row we need 6 and 8, I think. This is from 1 and 5. This column still needs 3 and 6. Oh, I remember this part. We need 3 and 6 in there. And I remember this part because there was an excellent piece of logic, which is if we try to fit 3 and 6 into those two cells, then by the Renban rules, those will have to be 4 and 5, which will contradict this pencil mark. I really like this logic. I'm not sure it's necessary, but this is something I really see. So this is from 3 and 6, and the other one is in here. Well, what else has to be seen? I'm also seeing that because of this 3, there is a 3 in here, so that is never a 3. And actually, because of this, this is also never a 6. So the previous logic is completely unnecessary, because that had to be a 3-6 pair anyway. So this is from 4 and 5 because of this one, and that's a 1 up there. All right, so 4, 5 here. So there's no digit from 4, 5 in here, which means that 3 is impossible. 3 would 3, 4, 1, 2. Well, actually, it seems to be still possible. So if this is a 4, then we can't have the 5 in the box. So that's a 3, that's 2, that's 1. And if that's a 5, knowing that we can't have a 4, they will have to be 5, 6, 7, 8. Oh, but 7 and 8 are not available. So this option of 5, 6, 7, 8 is not possible, so that's 4. 5, 4, 5, 4, 5, 4 by the clone property. So that's 4, 3, 2, and 1. And that's 3 and 2 here, 9 and 3 there, 6 down there, that's a 6. That's a 3, 2, 1, 3, not 1. Down there we get the 2 and the 9. This can only be a 5. And this is not a 5. And oh, this digit is the same as that, so that's a 4. So 1, 1, 4, 5, 4. That's not 4. And this box 4 can only be here, and this is a 2. And 2. This 6 now turns this into a 7. That's a 6. Let's clone them. And there are only a few digits to place just by the rules of Sudoku. That's not a 7. This can only be 9. This is a 7. That's a 5. And that's an 8, and that's it. That's a magnificent puzzle. I think I was right in not attempting to solve it during the contest because, well, I was utilitarian, I think, by solving basically all the rest with mistakes. But that was a really a splendid puzzle. A splendid use of the constraint, and a very nice way of having us find how the clone and Renban are dispatched. That's really nice. So huge thanks to Can Erturan for conceiving this puzzle. Thanks to everyone else for watching this video, and see you soon on SudoKanard.